I was trying to show you the pattern of brain development that Giedd discovered in his research. And it's broken down like this. Synaptogenesis happens from the point of conception, basically, shortly thereafter, until the third trimester of pregnancy. Okay, so when a fetus is developing in the first 6 months of fetal development, just makes sense. There would be a whole lot of synaptogenesis happening, right? The brain has to develop in the first place. And as that's happening, synaptogenesis is, of course, occurring, forming the brain from the very beginning. But interestingly, pruning seems to be happening in the third trimester of pregnancy. The last 3 months of pregnancy is a pruning period. And that might make some sense too, because you might think of it like the first 6 months of the pregnancy, the brain is basically developing from scratch. And in the last 3 months, the brain, the brain is like fine tuning itself. It's cleaning itself up, preparing to leave the uterus and enter the world and have a whole new set of experiences. So pruning is to be thought of as sort of this cleaning up process. Maybe think of pruning, and we'll talk more about it again, but as we did in the last video, pruning is this time when gray matter is cut away, right? Think of it as part of the evolutionary process, that the brain cleans itself up to make itself more efficient. All right, pruning is sort of natural selection when it comes to synapses. I almost said neurons, but it's not whole neurons. It's not necessarily that entire neurons die off. No, but the connections between those neurons, the synapses we keep talking about, some of these synapses, some of these connections are just unnecessary at certain times in life. They're not going to be needed. Okay, so synaptogenesis, even before we're born, it's happening, creating these connections that lead to whole networks of neurons, being able to communicate to each other throughout the brain. But in the last 3 months of pregnancy, some of those same connections, some of those parts of networks just aren't going to be needed anymore. They were needed to live in the utero, but they're in utero to be living in the uterus. But those same parts of networks aren't going to be needed when the child comes out to the world. So the brain goes through this cleaning up process to make it more efficient. And I started to say, maybe think of this, and it's corny, I know, but kind of think of it like when you use your cell phone and you're into different apps and things in your phone. If you leave those apps running in the background, it can drain your phone and make it really inefficient, right? Apps won't run as well. It'll drain your battery. Overall, the performance of your cell phone won't be very good unless you click into those apps and clear them out. And then that cleans up the functionality of your phone, makes it a more efficient processor. Pruning is like that for your brain in a metaphorical sense, right? That pruning, by cutting away these certain synapses, cutting away the dendrites, cutting away the axon terminal branches, it makes the brain a more efficient processor. And the first time that happens is in the last trimester of pregnancy before we're born. But then magically, or otherwise, when we're born, we go back to synaptogenesis. Giedd has discovered that the brain goes through these phases, synaptogenesis and pruning, right? Form a bunch of synapses and networks that we need based on what we experience, and then clean them up, make the brain more efficient, get rid of the stuff we're not using as much anymore, the stuff we don't need as much anymore. Maybe think of pruning that way as the opposite of LTP in a sense, right? Long-term potentiation is when neurons get better at firing because they're used so much. Well, when we're not using neurons so much, or at least a certain synapse so much, that synapse can be cut away, disintegrated. Natural selection. Only the most used synapses will survive the pruning process. Okay? So at birth, we go back to this stage of synaptogenesis. The infant brain is going to create a bunch of new connections based on what it experiences. We've seen the evidence of that already in the pictures from the previous recording. But interestingly, we're not exploding in synaptogenesis at the same rate for our whole lives. Giedd has discovered that around age 12, we go through another process of pruning, which is why I said you guys are now in your pruning phase because you're beyond the age of 12. Your brain is still going through the process of cleaning itself up, making itself more efficient, as we discussed with pruning. But for how long? I didn't finish the notes here. When is your pruning likely going to, according to Giedd, stop or at least slow down tremendously? Whatever the age is, would be the age that the brain is fully matured, the age where the brain is, quote unquote, finished developing for the most part. Now, this is controversial because look, there's research happening now that is suggesting that maybe the brain is never fully developed. Our whole lives, we might be creating more synapses. We might be pruning to some extent. But according to Gied's main research, the majority of this process is finished by age 25, generally speaking, our mid-20s. It's a little earlier for females, and about age 25 in males. But in humans, it's generally believed that the brain is matured, that it's mostly finished this pruning process around age 25. So our early to mid 20s is when our brain is going to be fully matured. That's huge. That's big. That means, you know, your brains are still going through this process of cleaning itself up that's not going to be finished until maybe you're out of college. You know, we think that people are adults at age 18 or 21, but the brain research is showing that full maturity in this sense isn't until closer to age 25. Brings up all sorts of interesting things to think about. Should we raise the drinking age to 25, the voting age to 25? I'm sure you have strong feelings about that. I'm not saying I believe it should be that way, but if the brain research is showing that, you know, our physical brains aren't finished maturing until that age, I think those questions are interesting ones. Now let's go back to some of Gied's research and suggest what else this might mean. If I, let's see, let me stop share the whiteboard and let's go back to this. Okay. Again, Giedd saw this decrease in gray matter. Again, not just because white matter increases over time, but now we know also because pruning has happened. So a lot of those dendrites that we weren't using a bunch got pruned away, cut away. That's gray matter gone. Axon terminal branches that weren't being used a whole lot were pruned away, cut away. Or maybe some of those terminal branches moved over and rewired somewhere else and hooked onto some other dendrite to make a new connection. Still, we understand pruning has happened. I want you to notice another pattern here with Giedd before we're all finished with this topic, because he and other researchers have learned this about the brain, and I mentioned this once before with brain stuff, but it's really important to understand that generally speaking, the human brain develops from bottom up and from back to front. Okay, this is true in an evolutionary sense. When we look at the human brain over the course of history and other animal brains, it's seen that the most primitive functions, the oldest parts of the human brain, are the lower, most rear parts of the brain. So like the medulla, the pons, the cerebellum, the thalamus, those parts of the brain that are low and to the rear. Let me go back to an MRI here that we saw. Okay, so here's the medulla, the pons, the thalamus, the cerebellum. This is what a lot of scientists call the reptilian brain, because even reptiles, alligators, all sorts of lizards, they have a medulla. They have a medulla. They have a pons. They have a thalamus. They have a cerebellum. But reptiles don't have very much of a cortex, if at all. So they're not capable of a lot of higher order thinking, but they can stay alive. They can pump blood, through their heart and keep their lungs going and regulate body temperature and all sorts of things that you're learning in your brain research. So this section of the brain is referred to as the reptilian brain for that reason. But these parts of the cortex up here, these wrinkled up parts of the cortex, like the occipital lobe, parietal, frontal lobe, and so forth, those are newer parts of the human brain. And we see these parts in other animals too, especially mammals have an occipital lobe and a temporal and parietal lobe. They're capable of, making memories, at least to some extent. And of course, having, complex visual and auditory systems that are linked to past and present. Our dogs can apparently recognize us and get happy when we come home and recognize strangers. That's, cortical activity. That's mammalian, okay? Part of the mammalian brain, easier said sometimes than others. Mammals have that part of the cortex. But then humans have this frontal lobe and its prefrontal cortex that allow for executive functions, okay? This is the executive part of the brain. And a lot of other mammals don't have this highly formed frontal lobe and its prefrontal cortex. This is very much a human part of the brain. It's still cortical, it's part of the cortex, but even dogs don't have very much of a frontal lobe. Cats even less. If I'm remembering research correctly, you can vet me on that fact and see if I'm right. But anyway, the frontal lobe is very much a human thing. So in the course of evolution, it's believed to be one of the newest parts of the brain. So again, the brain in all creatures and through human evolution is believed to have developed from bottom up. So these are the oldest, most primitive parts of the brain, and from back to front. Okay, we also see that in Gied's research. We see the pruning process. Remember, the blue areas on this diagram show like lesser areas of gray matter. Sorry, I should say areas of lesser gray matter, because either myelination has happened on axons or pruning has happened, cutting away unnecessary dendrites and axon terminal branches. So we're seeing this happening in the occipital lobe and the parietal lobe here, and it spreads from there as the child ages. We're seeing this apparent here, this up here, especially this pruning process, excuse me, this pruning process happening in the rear of the brain and continuing up, okay? The front parts of the brain are showing more blue here as the person ages. So even the pruning process is happening from back to front. And why is that so important? Why is that a big deal? Well, to simplify findings here a little bit, let's remind ourselves about that frontal lobe of the brain, the last part of the brain to fully mature or go through this pruning process. The frontal lobe with its prefrontal cortex way up front here, okay, front and bottom of the frontal lobe is the prefrontal cortex. That's the part of our brain that is most responsible for the super abstract things that make us human, like planning and understanding consequences and controlling our impulses, making decisions, having moral judgments, right? To be able to debate right from wrong. Those are very much prefrontal cortex functions. And those, again, are things that separate us from other animals. As far as we know, dogs, cats, certainly lizards, lemurs, giraffes, they don't have long, drawn out philosophical debates over ethics, right? They haven't had a renaissance with art and history and music and creations, largely because they don't have a frontal lobe which allows them to think so complexly about the world, again, as far as we can measure, as far as we can tell. um, so that frontal lobe, it's really important we understand those complex capabilities. Rewind the video and listen to those capabilities again if you need to, the things that make us human. Well, that frontal lobe is the last part of the brain to fully mature, to fully go through the pruning process. Again, at about age 25. So what's that mean? Maybe, and again, this is oversimplifying things a great deal, but some psychologists believe this could be part of the reason why teenagers, especially, do such risky things that they're not as likely to do when they get older, right? No offense, I'm not judging you. I myself, as a teenager, did things that I'm embarrassed of now. And no, I'm not going to tell you those stories, but I definitely took more risks as a 16-year-old in my life. I made stupid decisions, kind of lived in the moment a lot more often than I did when I was 26, let alone 36, or I'm not 46 yet, but and look, we shouldn't ignore the social and cultural differences for why that is. We live in an individualistic culture. We say things in America like, "Oh, teenagers, they need to find themselves. Of course, they need to take risks." And we're not going to hear that as much in a more collectivist culture. We should be reminded of that. We should also think of the social changes. Right now, at age 45, I'm not likely to take as many physical risks with my body because I have to worry about losing time from work or losing my career, not being able to pay my house payment or my bills or whatever. I didn't have to worry about those things at age 16. So, of course, those social differences in my life, the cultural differences that we live in, those things can go a long way in explaining the difference in adolescent behaviors and adult behaviors too. But let's come back to the brain stuff. I don't think we should ignore this. What Giedd might say, and again, this is a simplified way of saying it, is that your frontal lobe, the part of your brain that helps you make decisions and understand consequences and control your impulses, at age 16, 17, 18, 19, 20, 21, it's just that part of the brain isn't fully mature yet. It's not as effective as making those decisions as it will be when you're in your later 20s. So you're not right now capable of doing a good job of thinking things out, understanding consequences, understanding cause and effect. What's going to happen to you if this happens? This is not to say that you're stupid or you can't understand those consequences and that you can't control your impulses. It's just that maybe you'll be even better at doing those things when you're in your later 20s. And this, certainly leads to interesting discussions about legal matters. If a 16-year-old does something illegal, there have been lawyers who have brought in psychologists to a court setting to make an argument that, Your Honor, my client should not be held responsible for his actions when he vandalized that property. This psychologist is going to tell you, my client isn't working with a fully mature brain. You can't consider him responsible for his actions when his brain isn't allowing him to fully control his actions or understand his consequences or fully understand right from wrong. This is a hairy topic, super controversial, of course, and it's not something I'm going to try to talk with you here about in a One Direction recording. But definitely something to think about and to understand the complexities of behavior driven by the brain. And this gives us some reason to understand, or some understanding, I should say, of why behaviors might change as someone leaves adolescence and enters adulthood. Some of those behavioral changes, cognitive changes, could be affected by the pruning that continues throughout early adulthood and the maturation of the brain that happens in our early to mid 20s. Okay. And for now, make sure parents aren't around to hear me say this. For now, you can at least use this as a good excuse, right? If you do something stupid when you're in this quarantine time and you make some mistakes and it's some, terrible mistake that you can't even explain and you get grounded and, for I'm sure mom has good reason because you should have known better. At least for a while, you get to say, Mom, Dad, Grandma, whoever, it's not my fault. My frontal lobe isn't fully pruned yet. I did not understand the complexity of the situation I was in. I did not fully understand the consequences of my actions. I could not fully control my impulses because of my under pruned, not yet matured frontal lobe and prefrontal cortex. Sorry, you shouldn't ground me because, the brain. Do not use that as an excuse. You do the right thing. But anyway, there you go. Thought that might be interesting for you. Parents, grandparents, caregivers, I'm on your side. Your kids should be making good decisions. Just maybe this helps explain to you too why they do such stupid stuff sometimes. I know I did. Okay, everybody, that's brain stuff for now. I will see you later. Be ready with your questions when we do our Zoom sessions, please, and I will catch you later.